Hello students, welcome to Breedmark Academy. Myself LS Nanda. If you remember, then a long time back, around 1 year, I promised you people to give you a video on the part B section of KVPY SX stream for the year 2022. Part A section I have already discussed. I have made a video on that, so you can watch it if you have not watched it till now. But part B section was left over as I did not post any video for around 1 year due to certain health problems. But now I am again making videos, and as per my promise, I am going to discuss all the detailed solutions of part B section for this exam, right? So here is the first question. The question says the number of solutions of the equation x square plus y square equal to a square plus b square plus c square, where x, y, a, b, c are all prime numbers. That means we have to find the total number of solutions of this equation where all of these numbers are prime. Now this question is based on the concepts of number theory, and it's a quite logical and conceptual kind of question. Now let's write this equation. It's x square plus y square equal to a square plus b square plus c square. Now students, you must be knowing that all numbers that are prime are odd except 2. That means 2 is the only even prime number. Rest all the other prime numbers are odd, right? Now let's consider the first case, that is if x is not equal to 2, y is not equal to 2, a is not equal to 2, b is not equal to 2, c is not equal to 2. That means all of them are odd, right? All of them are odd prime numbers. I am discussing this first case. Now if x is odd, y is odd, a is odd, b is odd, c is odd, then on the left hand side we are going to get odd plus odd. Now odd plus odd is obviously what? It is even. And on the right hand side, what I'm going to get? I'm going to get odd plus odd plus odd 3 times. Now this is even plus odd, so that means this is odd. Now obviously any even number cannot be equal to an odd number, so that means this first case is not possible. That means it is not possible that all of these prime numbers are odd. That means at least one of them must be 2 if we have to find any solution for this equation, right? Now we discuss the further cases. Now students, I am going to take the case number 2. In the second case, I am taking all of them x, y, a, b and c equal to 2. So when I put in these values, the left hand side becomes x square plus y square, or 4 plus 4, that is equal to 8. And right hand side becomes a square plus b square plus c square, that is 4 plus 4 plus 4, which is 12. So LHS is not equal to RHS, right? So that means this case is also not possible. Now we move to the third case. In the third case, what I'm going to take, I'm taking any 4 of them as 2. So the first subcase of this case is that x and y and a and b are equal to 2, but c is not equal to 2. Now you can take anyone among a, b, c as not equal to 2. That is your choice. But you have to just take 2 of them as 2, and on the left hand side again both of them as 2. So LHS becomes 4 plus 4, again 8, and right hand side RHS becomes 4 plus 4, 8 plus c square. Now obviously if I want both of them to be equal, then c has to be 0, which is not possible because c is a prime number. So that means this is also not possible because LHS cannot be equal to RHS. Now the second subcase of this particular case is I am taking A, B, C, all of them equal to 2 and one among X and Y as 2. You may take X as 2 or Y as 2, but the second one should not be equal to 2. That means if you are taking X as 2, then Y should not be equal to 2. Or if you are taking Y as 2, then X must not be equal to 2. Now here LHS becomes how much? It is 4 plus Y square, and RHS is going to be equal to 12. Now obviously if I want both of them to be equal, Y square should be equal to 8. Again, not possible, right? So this case is also ruled out, right? Now students, in this way you have to categorize all the cases. This is little bit lengthier but very easy to understand. Now students, I'm going to discuss the fourth case, and in this particular case I'm taking any three of them equal to 2, right? So what can be the first subcase of this situation? I'm taking 2 on the left hand side, X and Y as 2, and 1 on the right hand side as 2. That means I'm taking C as 2. Fine. Now left hand side becomes 4 plus 4, which is 8, and right hand side becomes A square plus B square plus 4. Now if I want both of them to be equal to each other, then A square plus B square should be equal to 4, which is obviously not possible because there is no combination of two prime numbers such that the sum of their squares is equal to 4, right? So this case is also ruled out. Now in this particular case, another situation can be if I take all ABC as 2 and terms on the left hand side not equal to 2. So now left hand side becomes X square plus Y square, whereas right hand side becomes 12. Now let's analyze this situation. X square plus Y square is equal to 12. Now students, if I take X as 3 and Y as 3, this is not possible because 9 plus 9 is 18. Remember this thing that X and Y we cannot take equal to 2 because we have already set this thing in our condition. Now both 3 is not possible. If I take X as 3, that is one of them as 3, then we get this sort of equation. Again, not possible because Y square comes out to be 3. So obviously this case is also ruled out. Obviously you cannot take X as 5 or 7 because those are bigger numbers. So the other variable Y square will come as negative. That's not possible. So that means this case is also ruled out. Now we move to the remaining situations. Now students, this is the third subcase of the main case, and that is when one of the variables on the left hand side, suppose X is equal to 2, and two variables on the right hand side, suppose A and B, are equal to 2. Because we have to cover all the possible cases. Now left hand side becomes 4 plus Y square and right hand side becomes 8 plus C square, right? Now if I want to make both of them equal to each other, then I must get Y square minus C square equal to 4. Now we know that for any two odd prime numbers, if I find the difference of their squares, then the minimum value of the difference is going to be how much? It is going to be 5 square minus 3 square, that is 25 minus 9, which is 16. Rest in all other cases of two odd prime numbers, the difference is going to be bigger than 16. So that means if y square minus c square is greater than or equal to 16, then how can it be equal to 4? So this case is clearly rejected. Fine. Now we move to the next case. Now students, we discuss the fifth case, and that is any two of them are equal to 2. Now if I take the first sub case, I will be setting both x and y as 2, and a not equal to 2, b not equal to 2, c not equal to 2. Right? Now obviously LHS becomes 4 plus 4, which is 8, whereas RHS becomes a square plus b square plus c square. Now students, since all the three variables a, b, c are odd prime numbers, then odd plus odd plus odd certainly comes as a odd number, and odd cannot be equal to a even quantity. So that means this is also not possible, right? And the next subcase can be a equal to 2, b equal to 2. That is, two terms on the right hand side are 2, and rest all of them are not equal to 2. Now here LHS becomes x square plus y square, whereas RHS becomes 8 plus c square. Right? That means x square plus y square is equal to c square plus 8. Now students, since c is a odd prime number, then right hand side becomes odd plus even, which is odd, and since both x and y are again odd prime numbers, so odd plus odd is even. So that means this case is also rejected. They are very simple to understand, but it would be better if you discuss it case by case. Now what we are left with? Now students, the third subcase of this situation can be when one of the variables on the left hand side, suppose x, is equal to 2, and one variable on the right hand side, suppose a, is equal to 2. Right? Now left hand side becomes 4 plus y square, and right hand side becomes 4 plus b square plus c square. Now if I want to make both of them equal to each other, then I must get y square equal to b square plus c square. Right? Now since I know that y, b and c are all odd prime numbers, so this is odd, b square is odd, c square is also odd. Now right hand side becomes odd plus odd, which is even. Whereas this y square is odd, that means left hand side is just an odd number. So obviously odd cannot be equal to an even number. So this particular case is also rejected. Now we move to the last case of this particular question. Now students, we move towards the last case. This is the sixth case, in which only one of these numbers is equal to 2. Right? Now first subcase can be, if I take x as 2, rest all of them not equal to 2. Now the equation will become 4 plus y square equal to a square plus b square plus c square. Fine. Now just take y square onto the right hand side. You will be getting a square plus b square plus c square minus y square equal to 4. Right? Now students, we know that among these four variables a, b, c and y, none of them is 2 now. So that means they will start from 3. Minimum value of these prime numbers can be 3. So just look at this particular part. This is already positive, because it is the sum of the squares of two prime numbers, and this is the difference of two squares of two prime numbers. So let me find its minimum value, because since they cannot be 2, so the minimum value for y I can fix as 3 and c I can fix as 5. Fine. So the minimum value of this difference will become 25 minus 9, which is 16. Are you getting my point? Why I'm taking this minimum value? Because in any other case, whenever you select any two prime numbers randomly, starting from 3, then you will notice that the difference of their squares will always be more than 16. For example, you take 7 and 5. The square of 7 is 49. 49 minus 25, it is 24. So similarly, you can take any two prime numbers. So that clearly indicates that LHS is greater than or equal to 16, or I can clearly say it is greater than 16, whereas RHS is just 4. So there is no possibility that they can ever be equal. Fine. So no solution, even in this case. Right. Now we are very close to the end of this question, and this is the last sub case, and that is if I take one of the variables on the right hand side of this equation as 2. So what I'm doing, I'm taking a as 2 this time. Both x and y are not equal to 2. A is equal to 2, b not equal to 2, and c not equal to 2. So we'll be getting the equation as x square plus y square equal to 4 plus b square plus c square. Now just take this b square and c square onto the left hand side and rewrite this equation. It becomes x square plus y square minus b square minus c square equal to 4. Now students, just apply the same logic that we have done in the first sub case. Now I have rewritten this equation as x square minus b square plus y square minus c square. It is the difference of the squares of two prime numbers. This is also the difference of the squares of two prime numbers. So the minimum value, because again x, y, b and c, they cannot be equal to 2. They have to start from, we have to put in the values starting from 3. So the minimum value for this expression can be 25 minus 9, which is 16, and for this also 16. So that means in this particular case, LHS is what? It is greater than or equal to 32, whereas RHS is just 4. So again, there is no possibility in this situation. That means no solution. So hence, finally, we conclude that in all the cases, there was no solution, and hence option A is the correct one. That means 0 number of solutions. Now, students, this was a nice question involving lot of logical thinking and basic mathematics, or you can say number theory concepts. Now we move to the next question. Now students, this is the second problem. It says an ellipse x minus x naught whole square divided by a square plus y minus y naught whole square divided by b square equal to 1, where a is greater than b. That means it is a horizontal ellipse, is tangent to both x and y axis, and is placed in the first quadrant. Let f1 and f2 be two foci of the ellipse and O be the origin, with OF1 less than OF2. Suppose the triangle OF1F2 is an isosceles triangle with angle OF1F2 equal to 120 degree, then we are required to find the eccentricity of the ellipse. Now students, if you are familiar with the concept of shifting of origin, then you must be knowing that any equation of this form, that is x minus h whole square divided by a square plus y minus k whole square divided by b square equal to 1, represents a horizontal ellipse if a is greater than b with the center h comma k. That means the center of such an ellipse is going to be h comma k. So according to the given equation, the center of this ellipse is going to be x naught comma y naught, right? Now let's make the rough diagram. Since the ellipse is placed in the first quadrant and it is touching both the axes, so we'll be having this kind of figure. And let me make the major axis and the minor axis. Let me call this point as A and this as A dash, this as B and this as B dash, and this point as center, because center is placed at the intersection of major axis and minor axis, right? Now we know that AA dash according to the given equation is going to be 2A. So that means this AC distance will be just A. And similarly BB dash is going to be 2B. So BC will be equal to B. So that means I can conclude that the coordinates of C will be just A comma B. So that means X naught is going to be A and Y naught is going to be equal to B. Fine. And this is the origin. Now it is talking about two foci F1 and F2, and according to the given condition OF1 is less than OF2, that means F2 is going to be farther from the origin. So on this side we'll be having F2 and here we'll be having F1. Let's join OF1 and OF2, and this is the triangle OF1 F2 which is isosceles with angle OF1 F2 equal to 120 degree. Fine. That means we are going to have OF1 equal to F1 F2. Now students, you must be knowing that if the length of the major axis of horizontal ellipse is 2A and E is its eccentricity, then the distance between two foci is always 2AE, right? So that means OF1 is equal to 2A. And if by using the concept of shifting of origin, I write the coordinates of the foci F1 and F2, then I'm going to get x naught plus minus AE comma y naught. What you have to do? You have to just put x minus x naught equal to plus minus AE and y minus y naught equal to 0. So you'll be getting the coordinates of both the foci as x naught plus minus AE comma y naught. Now obviously the abscissa of F2 is going to be bigger than the abscissa of F1. So this is x naught plus AE comma y naught, and this is going to be x naught minus AE comma y naught, right? Fine. Now the length of OF1 is going to be under root of x naught minus AE whole square plus y naught square. So what I'm doing, I'm just squaring this equation and writing OF1 square equal to 4A square E square. So I will be reaching at the result x naught minus AE whole square plus y naught square equal to 4A square E square. Fine. Now students, we move further to solve this problem. Now students, I'm making the figure again. This is AA dash, this is BB dash. You can name the points by any letters. Now this was the figure. This is F1, this is F2, right? These 3 points are mandatory because they are given in the question O, F1 and F2. Now, since this angle is 120 degree, so just look carefully what I am going to do. The slope of F1, F2, this line is going to be how much? Because the coordinates of this point is x naught plus ae comma y naught, and coordinates of this point are x naught minus ae comma y naught. So the slope of f1 f2 becomes y naught minus y naught. This is just 0. And what is the slope of OF1? It is going to be y naught upon x naught minus ae, right? Now why I'm writing this? Because I have been given the angle made between these two lines. So that means if I use that formula tan theta equal to mod of m1 minus m2 upon 1 plus m1 m2, I can write tan 120 degree equal to how much? That is mod of y naught upon x naught minus ae minus 0 upon just 1, right? So that means in short I can write y naught upon x naught minus ae equal to tan 120 degree with plus minus sign. So what is tan 120 degree? It is minus root 3. Or we just can write this value as plus minus root 3, right? Now students, I have already told you that y naught is equal to b and x naught is equal to a. Fine. And we have also formed a equation x naught minus ae whole square plus y naught square equal to 4a square e square. Now from here, from this equation, what I can write? I can write y naught square as 3 into x naught minus ae whole square, or I can even write x naught minus ae whole square as y naught square by 3. So this is obviously simpler. I will be writing x naught minus ae whole square as y naught square by 3 in this second equation, or the equation that we found earlier. That means this one. So this is y naught square upon 3 plus y naught square is 4a square e square, or we can write 4y naught square upon 3 equal to 4a square e square. So now obviously y naught square is equal to 3a square e square. Now students, obviously since y naught is equal to b and it is lying in the first quadrant, and obviously b is always positive, so y naught is also positive. So do not write the negative sign before root 3 into ae. Just write y naught as root 3 into ae. Or b equal to root 3 ae. That means b upon a becomes root 3e. Now students, this is the very basic concept that in ellipse e square, if e is the eccentricity, then e square is equal to 1 minus b square by a square, because it's a horizontal ellipse. So that means I can write e square equal to 1 minus 3e square, or 4e square is equal to 1. Fine. So that means e square is equal to 1 by 4, or this implies e is equal to just half. Fine. So this is the right answer. Now you can check the suitable option and mark it. Now we move to the next problem. Now this is the next question. This question is little tricky in nature. It says in a triangle the lengths of the sides are integers. Suppose that the length of one side is 1 and the longest altitude is twice the shortest altitude. Let capital R and small r be the circumradius and the inradius of the triangle respectively. If capital R upon small r is equal to m is to n, where m and n are co-prime positive integers, then find the value of m plus n. Now students, by the term co-prime positive integers, we mean that both m and n are not having any common factor except 1. That means capital R upon small r has been expressed in the simplest form. after cancelling the common factor from the numerator and denominator, right? The second important thing in this question is the lengths of all the sides are integers, and we are given that length of one side is 1. So that means this must be the length of the shortest side, because the smallest positive integer is 1 only. So now let's make the triangle. Suppose this is the triangle ABC and BC is of length 1, which is the shortest side. Let's draw perpendicular from A onto BC. I am calling this point as D. Now students, this must be, AD must be the longest altitude. Why I am saying longest altitude? Because we know that in a triangle, half base into height is equal to the area of the triangle, right? So that means height can be written as 2 delta upon base. So that means since in all the cases, that means if we take any altitude, delta is going to remain same, but the length of the base will change. So if base is the smallest among all the 3 bases, that means in that case the height will come as the largest, because numerator is constant and we have taken the denominator as the smallest. Obviously the value of the fraction is going to be the largest. Fine. So that means AD is going to be the longest altitude. I am calling this length as H. Now let us take AC as the longest side. Hence BE, the altitude, will be the smallest altitude. And it is saying that longest altitude is twice the shortest altitude. So that means BE will have length equal to H by 2. Fine. Now, if this is H by 2, I am calling this length as, suppose, A units. Fine. So now I can write two equations. First is half H into 1 equal to delta, where delta represents the area of the triangle. And second can be half H by 2 into A equal to delta. Since delta is same in both the cases, so I can put half H equal to AH upon 4, right? H will cancel out, so we'll be getting A equal to 2 units, right? So that means the length of the longest side is going to be 2 units. Now students, here you have to pay attention. We are given that the lengths of all the sides are integers, and we have got the length of the smallest side as 1 and length of the longest side as 2. That means length of the third side should be either 1 or 2. It cannot be smaller than 1. It cannot be greater than 2 because it is lying in the middle. Fine. So if I take this particular length as 1, suppose AB as 1, this is not possible. This case is not possible because the sum of two sides of the triangle should always be greater than the third one. If I take AB as 1 unit, BC is already 1. So AB plus BC will become 2, which is equal to AC. That means I have to reject this case. So what should be the acceptable case? AB should be 2 only. Because if I take AB as 2, AC is already 2 and BC is 1, then this triangle is definitely possible because it is satisfying triangle inequality. 2 plus 2 is greater than 1, 2 plus 1 is again greater than 2. Fine. So that means by now we have got the lengths of all the sides. Now let's put the formula of capital R. What is that? It is ABC upon 4 delta. And what is small r? It is delta upon S. So what should be the value of capital R upon small r? It is going to be ABCS divided upon 4 delta square. Fine. Now let us do the calculations further. Now capital R upon small r we got as ABCS upon 4 delta square. ABC are the lengths of the sides. These are the general notations I am using, right? And we have got the sides as 2, 2, 1. S is the semi-perimeter. Let's calculate the semi-perimeter. It is going to be 2 plus 2 plus 1 divided by 2. So this is 5 by 2. And delta is, we know by Heron's formula, it is square root of S, S minus A, S minus B, S minus C. Fine. So that means delta square is going to be how much? S into S minus A into S minus B into S minus C. So from here, what do I get? I get capital R upon small r as ABCS divided upon 4S, S minus A, S minus B, S minus C. So obviously this S will cancel out up and down. Now just put in the values of all the sides and S. It becomes 2 into 2 into 1 divided upon 4 into S minus A. So it becomes 5 by 2 minus 2, which is 1 by 2. Then 5 by 2 minus 2 again it is 1 by 2, and 5 by 2 minus 1, which is this time 3 by 2. Fine. So let's do the calculations. It becomes 8 upon 3. Now students, obviously 8 and 3 are co-prime positive integers, which was our condition for M and N. So that means M is equal to 8 and N is equal to 3. So that means M plus N becomes 11. Hence option D is the correct one. Now we move to the next problem. Now this is the next question. The question says in a triangle ABC, cos 3a plus cos 3b plus cos 3c equal to 1. If the circumradius of the triangle ABC is root 3, then we are required to find the length of its longest side. Now let us start with the given equation. Cos 3a plus cos 3b plus cos 3c equal to 1. So if I use cos c plus cos t formula in the first two terms, I will be getting 2 cos 3a plus 3b divided by 2 into cos 3a minus 3b divided by 2. Now we shift this one onto right hand side. Further we can write this as 2 cos 3a plus 3b. So if I take out 3 common, inside the bracket I will be getting a plus b. I can replace a plus b by pi minus c, because we know that the sum of all the angles of a triangle is 180 degree, right? Into cos 3a minus 3b by 2. Now this particular value, if we apply the formula 1 minus cos theta equal to 2 sine square theta by 2, this can be written as minus 2 sine square 3c by 2 equal to 0, right? Now this becomes 2 cos 3 pi by 2 minus 3c by 2 into cos 3a minus 3b by 2 minus 2 sine square 3c by 2. Now students, cos 3 pi by 2 minus 3c by 2. So this is which quadrant? 3 pi by 2 minus theta. This means it is third quadrant. So cos 270 degree minus theta is nothing but minus 2 sine theta, right? So this becomes minus 2 sine 3c by 2. I treated 3c by 2 as theta into cos 3a minus 3b divided by 2 minus 2 sine square 3c by 2. Now you can clearly see this sine 3c by 2 will come common. Now let us move ahead. Now if we take minus 2 sine 3c by 2 common, inside the bracket I am going to get cos 3a minus 3b divided by 2 plus sine 3c by 2, right, equal to 0. Now this can be written as minus 2 sine 3c by 2. Inside the bracket we can write this as cos 3a minus 3b by 2, and this 3c, right, 3c it is. So I can replace this as sine of 3 by 2 inside the bracket. Now I am replacing pi c as pi minus a plus b, because we know that the sum of three angles of a triangle is 180 degree. So now this becomes minus 2 sine 3c by 2. Inside the bracket it is cos 3a minus 3b divided by 2, right? Now this becomes how much? This is sine of 3 pi by 2 minus 3a plus 3b divided by 2, right? Minus 2 sine 3c by 2 is common, and this is how much? It is cos 3a minus 3b by 2. Now students, this is sine 3 pi by 2 minus theta. So now this becomes how much? This is minus cos theta, means minus cos 3a plus 3b by 2. Now here at this stage we can apply the formula cos a minus b minus cos a plus b, because we will be treating 3a by 2 as a and 3b by 2 as b, right? So now I can write minus 2 sine 3c by 2 into, inside the bracket it is going to become 2 sine 3a by 2 into sine 3b by 2, because we know that cos a minus b minus cos a plus b is nothing but 2 sine a sine b, right? Now students, from here what we are getting? The product of these three signs is 0. What does this indicate? It indicates either of them is 0, or I can say at least one of them must be 0. Now if I say at least one of them is 0, then what do I get? Now from this equation we conclude that either sine 3a by 2 is 0, or sine 3b by 2 is 0, or sine 3c by 2 is 0. Now clearly 3a by 2 must be equal to pi. This is the only possible case. So that means a becomes 2 pi by 3. Now if I put sine 3b by 2 equal to 0, what do I get? I will be getting 3b by 2 equal to pi. Why I am putting them as pi? Because sine theta is 0 only when theta is equal to n pi. That means integral multiple of pi. So obviously, since these are angles of triangle, we cannot put 3a by 2 equal to 0. That is not possible. And I can not put the value of 3a by 2 as 2 pi also, or greater than 2 pi, because in that case a will become 4 pi by 3, which is again impossible, because none of the angles of the triangle is greater than 180 degree. That is impossible. Fine. So only possible case for these values is pi. So if 3b by 2 is equal to pi, then b becomes 2 pi by 3. And from here what do we get? We get 3c by 2 equal to pi, means c is equal to 2 pi by 3. Now students, this is a very important point, that at the same time all of these cannot prevail. In fact, only one of them is going to be true, because in a triangle we can have only one obtuse angle. Two obtuse angles are not possible. So that means in any case, whatever the case it is, suppose I am taking the first one. If suppose this angle is 2 pi by 3, I am not calling this as A, B or C. I know that only one of them is going to be 2 pi by 3. So I am just taking one of the angles of the triangle as 2 pi by 3. Fine. You can take this angle as A or B or C. That's your choice. Now the side opposite to this particular angle 2 pi by 3 will be the longest, because we know that in any triangle the greater side has the greater angle opposite to it. Since it is the greatest angle, so that means the side opposite to it must be the greatest, right? And we have to calculate this greatest side now, or the longest side. So this is how much it is going to be. By sine rule, a is equal to 2r sine a. You can write B as 2r sine B. Similarly, C as 2r sine C. What is R over here? R is the circumradius or the radius of the circumcircle of the triangle. Fine. And we are given that R is equal to root 3. And what is sine of 2 pi by 3? It is going to be root 3 by 2. Because sine of 2 pi by 3 is same as sine pi by 3. Fine. So what is the final answer? It becomes 3. So that means 3 is our longest side. Now it can be A, B or C depending upon which angle is 2 pi by 3. Fine. So we are just concerned with the numerical value of the longest side, and that is 3. So hence option C is the correct. Now we move to the next question. Now students, this is also a nice problem based on the topic of solution of triangles. In fact, in this question, you will be required to use triangle inequality. Now, question says, suppose that the sides ABC of a triangle ABC satisfy B square equal to AC. That means the sides of the triangle are in geometric progression. Then the set of all possible values of this given expression is. Now, basically, in this question, we have to find the range for this particular expression. Now, let us simplify this expression. It is sine A into cot C. Cot C I can write as cos C upon sine C plus cos A whole divided upon sine B into cot C. So it can be written as sine B into cos C upon sine C plus cos B, right? So if I take LCM in the numerator, I am going to get sine A cos C plus cos A sine C divided upon sine C, right? Whole upon denominator of this expression can be written as sine B cos C plus cos B sine C divided upon sine C. Now obviously this sine C will cancel out, and this expression becomes nothing but sine A cos C plus cos A sine C whole divided upon sine B cos C plus cos B sine C. Now students, in the numerator, it is a formula, direct formula. Sine A cos C plus cos A sine C can be written as sine of A plus C. And in the denominator, again, it's a direct formula. It can be written as sine of B plus C. Now, sine of A plus C means sine of pi minus B, which is nothing but sine B. And in the denominator, sine of B plus C means sine of pi minus A, which is sine A, right? So that means now we have to calculate the range for sine B upon sine A. Now, we are given that B square is equal to AC. Fine. So what does this mean? How can we use B square equal to AC in this question? Now we are given that B square is equal to AC. It means B upon A can be written equal to C upon B. Or I can put this ratio equal to R. Let's say this is the common ratio because ABC are in geometric progression. So that means sides I can write as A, AR and AR square. And what I need to get in this question now, I need to get sine B upon sine A. We have already calculated that expression. Now students, if you have read sine rule, then you must be knowing A upon sine A, because ABC were the sides of the triangle ABC in general notation. So that means small a is the side opposite to angle A. Small side B is opposite to the angle B. It's like this. Suppose this is the triangle ABC. Then this is A, this is B, and this is C. This is the general notation. Now A upon sine A will be equal to B upon sine B according to sine rule. I am not using equal to C upon sine C because it is not required. So from sine rule, I will be getting this. So that means sine B upon sine A can be written as what? It can be written as B upon A. and I have supposed this value as small r. This is the common ratio of this GP, right? So that means we have to get the range for small r in this question. Now, which concept at this stage can we use? Because we are not given any other thing regarding this triangle. Now, one thing strikes us, and that is we can use triangle inequality. Because in any triangle, the sum of two sides is always greater than the third one. So I can write a plus ar greater than ar square. This is the first triangle inequality that I can use. So that means 1 plus r will be greater than r square, or I can say r square minus r minus 1 will be less than 0. Now let's make the factors of this quadratic expression and use wavy curve method to find the interval for r. So the value of r comes as minus b plus minus root d, b square minus 4ac, it becomes 5 upon 2. So the value of r comes as greater than 1 minus root 5 by 2 to 1 plus root 5 by 2. Now students, obviously r is going to be positive because these are the sides of the triangle. So from here we conclude that r should be greater than 0 because 1 minus root 5 is just negative value. So I am taking r greater than 0 to 1 plus root 5 by 2. So this is the first, I am calling this inequality as inequality number A. This is the first inequality that I have got, right? First interval for r that I have got. Now we similarly write another intervals. Another triangle inequalities we'll be using to find more intervals. Now let's do the calculations. Now students, we can write the second inequality as ar plus ar square greater than a. Now if I divide both sides by a, I will be getting r square plus r greater than 1 or r square plus r minus 1 greater than 0. Now let's factorize this. I am finding the factors for r square plus r minus 1. Now factors will be r minus root 5 minus 1 divided by 2, then r minus 1 minus root 5 divided by 2 greater than 0. So if you use wavy curve method, you will be getting r greater than root 5 minus 1 by 2 or r smaller than minus 1 minus root 5 divided by 2. Now students, this particular interval we have to reject because r cannot be negative. So that means we have to accept this one only. R should be greater than root 5 minus 1 divided by 2. I am calling this inequality B. Now earlier we got r greater than 0 less than root 5 plus 1 divided by 2. And this time we have got r greater than root 5 minus 1 divided by 2. And please note over here that you have to find the intersection of all these intervals of r which you are getting from these inequalities, because ultimately we have to satisfy all the triangle inequalities. Fine. Now the last triangle inequality which we can write is ar square plus a greater than ar. So it becomes r square minus r plus 1 greater than 0, right? Now clearly this is true for all real values of r. Why I'm saying this? Because when you try to find the discriminant for the polynomial on the left hand side, it is coming as negative. Or we can also express it like r minus half whole square. It is r square minus r plus 3 by 4. Because 1 by 4 will come, I will add 3 by 4 to it. Now this is obviously greater than 0 for all real values of r. That means there is not going to be a particular interval for r. It is true for any real value of r. So that means here I can write r belongs to any real number, or r is between minus infinity to infinity. But actually r cannot be negative, so that means we can write r from 0 to infinity. Now students, we have to take the intersection of all these intervals, and the final intersection comes as R belongs to the interval root 5 minus 1 upon 2 to root 5 plus 1 upon 2, because we got inequality B as R greater than root 5 minus 1 whole divided by 2, and from the first interval we got R lying between 0 to root 5 plus 1 upon 2. So when we take the intersection of all these three inequalities, because the third one is the superset of all of them, it is 0 to infinity. So intersection will be this one only, root 5 minus 1 by 2 to root 5 plus 1 upon 2. So hence option C is the correct one. Right? Now we move to the next question. Now this is the next problem. It's a nice question on the properties of binomial coefficients. The question says, let NCK equal to, the formula is given, factorial n upon factorial k into factorial n minus k. Then we have to check in which particular interval this sum lies. And the sum is 1 upon 2 to the power 10 into summation k varying from 0 to 10, 10ck into k square. Now let's simplify this sum. It is 1 upon 2 to the power 10 into summation k varying from 0 to 10. Now here students, I am writing k square as k into k minus 1 plus k. We know that k into k minus 1 is k square minus k. So just shift k onto the left hand side. You will be getting k into k minus 1 plus k equal to k square. Now why I am doing this? You will just come to know about this in the next step. This is now 1 upon 2 to the power 10 into summation k varying from 0 to 10. This 10ck we can write as 10 upon k into 9ck minus 1. And further this 9ck minus 1 I can replace by 9 upon k minus 1 into 8ck minus 2. Why we are doing this? Because we have to cancel this particular term k into k minus 1 when we multiply 10ck with this particular term, right? Because otherwise the sum cannot be found. So this is 10ck into k minus 1. This is one summation, and now I am separating the another one as 1 upon 2 to the power 10 summation k equal to 0 to 10, 10ck into k. And let me tell you, to get this particular expression, which particular property we have used? We have used NCR equal to n upon r into n minus 1 CR minus 1. You can easily use this property, and you must remember it because it's widely applicable in many competitive exams whenever the question on binomial comes. Now here I can write this as 1 upon 2 to the power 10 into summation k varying from 0 to 10, right? 10ck, we have already found the value of 10ck as 10 upon k into 9 upon k minus 1 into 8ck minus 2, right? So I can write over here 90. This k into k minus 1 will cancel with this k into k minus 1. So I'll be getting just 90 into 8 ck minus 2. Fine. And this particular limit k equal to 0 now does not make any sense because this term will become absurd. So I am replacing this 0 by 2. That means my terms are going to start from k equal to 2 and they will go till k equal to 10. Fine. Plus 1 upon 2 to the power 10 into summation. Now we'll be repeating the same process in the second term also. But here we are just going to write 10ck as 10 upon k into 9ck minus 1 because we have to just cancel out this k only. So now it will become 10 into 9ck minus 1. Fine. I think it should be clear till here. Now we move further. Now this expression will become In the denominator, I can write 2 to the power 10. In the numerator, 90 will be taken out common from the first term, so or the from the first summation. So 90 into summation k varying from 2 to 10, it's 8 ck minus 2 plus 10 we can take out common from the second summation, and now we can change the lower limit of this summation because earlier it was k equal to 0, but now k equal to 0 does not make any sense because here we are having 9 ck minus 1. Fine, so k will start from 1, so 1 to 10 it is going to be. Fine. Now students, we know that nc0 plus nc1 plus nc2 and so on till ncn is nothing but 2 to the power n. It's a very popular binomial coefficient relation. You must remember this. Now this is 90 into. So this 8ck minus 2 summation when k goes from 2 to 10 will become what? 8c0 plus 8c1 plus 8c2 and so on till 8c8. So this is nothing but 2 to the power 8, right? By applying this property. Plus now here it is 10 into. Here we'll be getting 9c0 plus 9c1 plus 9c2 and so on till 9c9, which becomes 2 to the power 9 whole divided upon 2 to the power 10. Fine. So now what I am doing, I am cancelling 2 to the power 8 up and down. I will take out 2 to the power 8 common from the numerator, and in the denominator it is already 2 to the power 10. So we'll be cancelling out this 2 to the power 8 factor. So now we'll be getting 90 plus 10 into 2, which is 20 in the numerator, and here it is 2 to the power 10. So when we cancel this 2 to the power 8, here it becomes 4 only. That means this is 110 by 4 or 55 by 2, which is nothing but 27.5. Now clearly students, it lies in the interval 27 to 28. That means option B is the correct one. So it was a nice problem on the concept of binomial theorem or binomial coefficients. Now we move to the next question. Now students, this is the next problem. I would say this is really a challenging problem. The question is the number of continuous functions f closed 0 to 3 by 2 to open 0 to infinity satisfying this equation. Now an equation in the form of integral is given to you, and the very important thing about this question is that fx is going to give us positive values. Why? Because the range of fx is open 0 to infinity. So please note this thing that fx is going to be positive in this interval 0 to 3 by 2. Now first of all, what we have to do, we add these two integrals and combine them into a single integral. That is 0 to 3 by 2 4fx plus 125 upon under root of fx plus x square dx. Right? I can write the left side of this equation in this way, and right side is just 108. Now to create symmetry, what I am doing, I am writing this again as 0 to 3 by 2 integral. I am adding 4x square on the left hand side and also subtracting 4x square on the left hand side. That means I am writing this as 4 times fx plus x square plus 125 upon under root of fx plus x square, and then I am subtracting 4x square like this. Right? Now why I am doing this? Because my actual intention is to apply the concept of AMGM inequality in this problem, because that is the only way to solve this. And since this particular expression was having under root of fx plus x square in the denominator, so the same thing I have created in the first term, It was originally 4 into fx, so I added 4x squared to it. Fine. Now you can see that in the next few steps, we'll be able to apply AMGM rule. Now just simplify this equation. It will become 0 to 3 by 2, 4 times fx plus x square plus 125 divided upon under root of fx plus x square dx. That 4x square part I'm taking to the right hand side. So this now becomes 108 plus 4x square integral 0 to 3 by 2. Right? I have just detached that particular part minus 4x square dx and brought it to the right hand side. Now left will be just as it is. Left side you do not have to change. And on the right hand side, evaluate this integral. It will become 4 into x cubed by 3 under the limits 0 to 3 by 2. So if we just simplify this, what do we get? It is 4 by 3 into 27 upon 8 minus 0. So when I just simplify this, I'll be getting 108 plus 9 by 2. Now 108 plus 9 by 2 is nothing but 225 upon 2. Right? Now students, it's not easy to apply AMGM rule. First of all, you will have to create such kind of expression where we can get the beneficial result. Because whenever we apply this rule to any function, then on the right hand side, we prefer to get a number. Now, what I am doing, I am taking three expressions, 4 times fx plus x square. Then what I am doing, I am taking the half of this expression. That is another number I am taking is 125 upon 2 times under root fx plus x square. And then again 125 upon 2 times under root of fx plus x square. I have taken three numbers. To these three numbers or three expressions, I'll be applying AMGM rule. Now why I'm doing this? Because when I treat this value as A, this as B, this as C and apply AMGM rule, then on the left hand side I will be getting A plus B plus C by 3, and on the right hand side it is going to be ABC cube root. Now you can clearly see this fx plus x square and this under root of fx plus x square into under root of fx plus x square will just cancel out, and on the right hand side we'll be getting a pure numerical value. Fine. Now we move further. Now let's apply AMGM rule to these three expressions. This question actually involves tricky thinking. This is why I said it's a challenging problem. Now if you apply AMGM rule, then on the left hand side this is the AM of these three numbers or three expressions, and this is greater than or equal to cube root of their product. Now what is going to be their product? As I already told you, this fx plus x square and this under root fx plus x square and under root fx plus x square, they will all cancel out to give you 4 into 125 by 2 into 125 by 2 cube root. This 2 and 4 will also go away. Now 125 is how much? 125 is 5 cube. So this is 5 power 6, and 5 power 6 cube root means 5 square. Right? So that means I can now say that 4 into fx plus x square plus 125. Now I am just clubbing both of them upon under root fx plus x square is just greater than or equal to 75. Just take that 3 in the denominator and multiply it on the right hand side. Fine. This is correct. Now, if I integrate both sides from 0 to 3 by 2, what do I get? I'll be getting 0 to 3 by 2 4 times fx plus x square plus 125 upon under root fx plus x square dx is greater than or equal to integral 0 to 3 by 2 75 dx. Fine. Now students, if you find the value of this integral, it is going to be 75 into 3 by 2, which is nothing but 225 by 2. Now if you just go back and check what was our original equation, the value of this left hand side expression was given to us as 225 by 2 only. So that means in this particular case, AM is becoming equal to GM. And you must be knowing, whenever AM of positive numbers becomes equal to their GM, then the numbers are equal. Fine. That means this quantity will be equal to this quantity, which is further equal to this quantity. Now let us move further. Now find the function. We will just make the comparison among these functions. So it is 4 times fx plus x square. It must be equal to 125 upon under root of 2 times under root of fx plus x square, right? So from here I will be getting fx plus x square whole power 3 by 2 equal to 125 upon 8. So if I square this quantity and take its cube root, I'll be getting fx plus x square equal to, this is 5 by 2 square, right? I have taken power 2 by 3 on both the sides, or you can even do the squaring on both sides first of all and then take the cube root. Now clearly fx becomes 25 by 4 minus x square. So that means there is only one such function. Fine. Hence the B option is the correct one. Now we move to the next question. Now this is a nice question based on the concepts of greatest integer function and fractional part function. These functions are very important from JEE main syllabus or JEE advanced syllabus point of view. So if you are preparing for these exams, you must be very thorough with these functions. The question says, for each real number x, let, this is the notation of GI function, denote the greatest integer less than or equal to x, and let fractional part of x equal to x minus GI function x. Then the smallest positive integer capital M for which the value of this integral is greater than 1 is. Now to solve for the value of this integral, we'll be using the property a to b fx dx equal to a to c fx dx plus c to b fx dx. I hope you must have read this property, where c is a number lying between a to b. So that means we'll be writing this 1 to m part as 1 to 2, one integral, plus 2 to 3 another integral, plus 3 to 4 another integral, and so on. Why we are doing this? Because we know that whenever x lies between greater than or equal to 1 to 2, in this interval if x is lying, then the value of GF function x will be 1 only. So similarly we can say if x is greater than or equal to less than 3, then the value of GF function x will be 2. So that will help us to find the value of this integral. Now 1 to m it is, so I am writing 1 to 2 first. fractional part of x to the power gf function x dx. Then I will be writing plus 2 to 3 fractional part of x to the power gf function x dx, and so on. I will stop at that particular integral where the sum of these integrals will be greater than 1, just greater than 1. There we have to stop and note the upper limit of that last integral. That will be the smallest positive integral value for m, right? That means that is going to be our required answer. Now let's calculate the values of these integrals. This is the first approach. I will be telling you a shortcut also. Now this is the general approach I am following. This value will be 1 to 2. GF fractional part of x in this case can be written as x minus 1, because here x was lying in 1 to 2 interval. So that means here GF function x will be just 1. So x minus 1 to the power 1 dx, right? Let us calculate it. It becomes x square by 2 minus x under the limits 1 to 2. So its value comes as 4 upon 2, which is 2. 2 minus 2 is 0, minus half minus 1. That means the value of this integral comes as just half. That means we need to add few more integrals. Let's calculate the second one. This comes as integral 2 to 3 x minus 2, because now this time the value of gf function x is going to be 2. So this becomes x minus 3, x minus 2 whole cube divided by 3 under the limits 2 to 3, right? So now when we calculate this, this comes as 3 minus 2, which is 1 upon 3, and minus it is 0. So that means till now we have got the value as half plus 1 by 3, which is still smaller than 1, because it is just 5 by 6. So that means one more integral we need to add, and that is 3 to 4 fractional part of x to the power greatest integer function dx. So this becomes x minus 3 to the power 3 this time from the limits 3 to 4 dx, right? So this comes as x minus 3 whole power 4 upon 4 under the limits 3 to 4. So when we calculate this value, it comes as 4 minus 3, which is 1 upon 4 minus 0. Fine. Now this till here, the value comes as half plus 1 by 3, which is 5 by 6 plus 1 by 4. Let's calculate this. It comes as 12 as the LCM. And in the numerator, I am going to get 10 plus 3, which is 13. Obviously, this value comes as greater than 1. So that means we need to stop here, because we have fulfilled the condition of the question. So hence, this is the last value or the upper limit of the last integral. So that means this is going to be the smallest integral, positive integral value of m, and this is 4. So that means option C is going to be the correct one. Now this was the general approach that I have followed. Now about which shortcut I was going to tell you, that is, now here the shortcut is, you are noticing that type of integrals, all of these integrals are coming in this form, a to a plus 1, because we are writing the upper limit just one integer greater than the lower limit. So suppose the lower limit is 2, then we are writing upper limit as 3. If the lower limit is 3, we are writing the upper limit as 4. So that means I can set the limits as a and a plus 1. And since x lies between a to a plus 1, so that means now the value of gf function of x will be just a, right? So I can write the integrand as x minus a to the power how much? It is again a, because it was just x minus gf function of x whole power gf function of x. So now this is the shortcut. That means you have to calculate only this particular integral. Rest all the integrals, the values of all these integrals you can calculate by putting the value of a in the answer of this integral. Now let's calculate the answer for this. This comes as x minus a to the power a plus 1 divided upon a plus 1 under the limits a to a plus 1, right? So when I put a plus 1 over here, it becomes just 1 upon a plus 1 and minus 0. So that means these integrals are going to come in this particular form. That means the first was 1 upon 2, because in the first integral you can see we had the value of a as 1. Then next was 1 by 3, third was 1 by 4, and so on you can calculate. Now students, why I'm telling you this particular shortcut, you can use this shortcut in this question as well. But if suppose the value of integral or the required integral is not given greater than 1, it is given suppose greater than 10, then it will become really hard to calculate all the integrals like this. So in that case, you will be needing a shortcut. So that's why I'm giving you this shortcut. The values of these integrals you can write like 1 upon 2, 1 by 3, 1 by 4, 1 by 5, and then you can add them. Fine? Because addition may take little time, but finding integrals is not going to take much time. So now here we end this problem. It was a nice question. Now we move to the next problem. Now this is the next question. It says in a collection of 10 tickets, there are 2 winning tickets. From this collection, 5 tickets are drawn at random. Let P1 and P2 be the probabilities of obtaining 1 and 2 winning tickets respectively. Then P1 plus P2 lies in which of the following intervals? Basically, we have to find the value of P1 plus P2, and then we'll be seeing in which particular interval it falls. Now, P1 is the probability of drawing 1 winning ticket, right? And there are total 10 tickets, and we have to draw 5 tickets in all out of them, right? Now, clearly the exhaustive number of cases is going to be 10C5, because we are drawing 5 tickets out of the given 10 tickets. But while writing favorable number of cases, you need to be careful. It is going to be 2C1. Out of the 2 winning tickets, I am drawing only 1. Into, at the same time, I have to draw 4 tickets more out of the remaining 8, because these 8 tickets are non-winning tickets. Fine. So it is 8C4. So this becomes the value of P1. Similarly, we can find the value of P2. Exhaustive number of cases in P2 will be same. It is again 10C5. And in the numerator, I can write 2C2, because this time I am drawing 2 winning tickets from the given 2 winning tickets. That means both of them we have to draw. Into, it is going to be 8C3, right? So now if I write the value of P1 plus P2, it becomes 10C5 in the denominator. In the numerator, it is 2C1 into 8C4. We know that 2C1 is 2 only, so it is 2 into 8C4. Plus 2C2 is again 1. It is just 8C3. Right? Now students, there are 2 ways to solve this particular expression. Either you can use the formula NCR equal to factorial n upon factorial r into factorial n minus r and put in the values, do the calculations. You will get the answer. Another way which can be used in this particular case is the properties of binomial coefficients. So I am preferring this one, this second method. I am writing 2 into 8C4 as 8C4 plus 8C4, and this 8C3 is also there, upon 10C5. Now we know that NCR plus 1 is nothing but n plus 1 CR plus 1. So that means this 8C4 plus 8C3 can be written as what? It can be written as 9C4 divided upon 10C5 it is. Now we know that another property is NCR equal to n upon r into n minus 1 CR minus 1. So that means this 10C5 I can write as what? It is 10 upon 5, which is 2 into 9C4. right? So that means in the denominator it is just 9c4 into 2. Fine. Now 1 by 2 I am taking out common. In the bracket I will be getting 8c4 upon 9c4 plus 1. Now students, this 8c4 upon 9c4 will have to solve by using the formula NCR equal to factorial n upon factorial r into factorial n minus r. But here the calculations are going to be quite easy. So factorial 8 upon factorial 4 and it is 9c4, so it is factorial 5 into factorial 4 in the numerator upon factorial 9. So let's do the calculations. This becomes only 5 and this is 9 over here. So that means this particular expression can be written as what? Half into 1 plus 5 upon 9, which is nothing but 14 upon 9. So that means the value of P1 plus P2 becomes finally 7 upon 9. Right? Now, if you just convert this into decimal form, it is 0.77 something. But you can also compare it with 3 by 4 because the value which is very close to 7 upon 9 is 3 upon 4. So there might be little confusion if you do not solve it properly. There might be little confusion whether it is going to be smaller than 3 by 4 or greater than 3 by 4. Fine. The one way is to simplify 7 upon 9, correct up to 2 places of decimal. You will get the answer. But if you do not want to do it that way, what you can do, you can compare 7 by 9 with 3 by 4. I am assuming 7 by 9 greater than 3 by 4. So when I cross multiply, I will be getting 28 greater than 27, which is true. That means our assumption is correct. 7 upon 9 is greater than 3 by 4. So that means this value 7 upon 9 clearly lies in which interval? It lies in 3 by 4 to 1. Because obviously 7 upon 9 is smaller than 1. So that means option C is the correct one. Fine. Now we move to the last question of this video. Now students, this is the last question of this video and the question says the number of real values of x at which function fx, which is a determinant, is not differentiable. That means first of all I have to get the value of this determinant and then find those values of x for which fx is not differentiable. Now if we look carefully, then to solve this question we must know the properties of determinants, the concept of modulus sign or modulus function, and the concept of differentiability. So that means this question involves 3 concepts. Now first of all, what I am doing, I am using the properties of determinants and I am subtracting third row from the first row. That means R1 tending to R1 minus R3, and simultaneously I am subtracting the third row from the second row. That means R2 tends to R2 minus R3. Why I am doing this? Because I want to simplify this determinant and I am creating 2 zeros in the first column. So the determinant will now look like this. Now let's expand along the first column. So the value of fx comes out to be mod of x minus mod of x minus 2 inside the bracket into, it is going to be x minus 1 whole square minus x minus 2 whole square. Now students, we can use a square minus b square formula to simplify or to get the value of this expression. So it is x minus 1 plus x minus 2. That means 2x minus 3 into x minus 1, then minus x plus 2. So this is just 1. So that means this expression, this part will be just 2x minus 3. Fine. And then we'll be having minus sign into mod of x minus 1 minus mod of x minus 2 into, it is going to be x square minus x minus 2 whole square. So x square minus x minus 2 whole square, again I'm using a square minus b square. It is a plus b, that means 2x minus 2 into a minus b. So it is x minus x plus 2, which is 2. So that means I can write 2 over here, and this is 2x minus 2. Fine. Now I'm further simplifying this expression and rewriting it as mod of x minus mod of x minus 2 into 2x minus 3, and then minus 4 into mod of x minus 1 minus mod of x minus 2 into x minus 1. What I have done, I have taken out 2 common from this particular part, right? Now students will be simplifying this modulus function which has been used in this function fx, and then we'll use the concept of differentiability. Let's move further. Now students, to solve this expression, which is fx equal to mod of x minus mod of x minus 2 into 2x minus 3 minus 4 times mod of x minus 1 minus mod of x minus 2 into x minus 1. I will have to simplify, or you can say remove these modulus signs. Now, if you have studied the modulus function properly, then you must be knowing to solve such kind of functions. What I am going to do, what we should do, we should put all of these modulus expressions equal to 0, just to get those critical values of x for which these modulus functions will become 0. Now we get 3 points, 0, 1 and 2. So that means we'll be dividing the entire real number line into 4 regions. This is the first region, that is for x less than 0. Then this is the second region between 0 and 1. This is the third region between 1 and 2. And this is the fourth region greater than or greater than or equal to, right? Now this process will help us to resolve this function, and finally we'll be using the concept of differentiability. Now I'm considering the first case, that is x less than 0. Now students, when x is less than 0, that means mod of x is going to be minus x. Mod of x minus 1, since x is smaller than 0, that means x is smaller than 1. So this is going to be minus of x minus 1. That means this is 1 minus x. Why? Because modulus of x is always x when x is positive, and modulus of x is minus x. That means modulus attaches minus sign to its input whenever the input is negative. Fine. So similarly, mod of x minus 2, since x is smaller than 2, so this is going to be minus of x minus 2. That means 2 minus x. Now let us put in these values to get the value of the function. So here it becomes x minus x. Then this is 2 minus x, and minus of 2 minus x will become x minus 2. Fine. Into 2x minus 3 as it is. Then we have minus 4 into, this is 1 minus x. This is 2 minus x attached with minus sign. So this is x minus 2. This is x minus 1. Now this becomes minus 4x plus 6. Minus 4 into So finally we get 2 as the value of the function. So that means fx is equal to just 2. It's a constant function when x is negative, right? Now let us move further and discuss the second case. Now for case number 2 or region number 2, it is x greater than or equal to 0 but less than 1, right? So now if you simplify the expression fx, what you are going to get? Now since x is positive, so mod of x will be equal to x. But since x is less than 1, so mod of x minus 1 will be 1 minus x. Similarly, mod of x minus 2 will be 2 minus x. Now just put in these values to get the expression as x plus x minus 2, that means 2x minus 2 into 2x minus 3 minus 4 times. It is going to be 1 minus x plus x minus 2, which is minus 1 into x minus 1. So that means it is 1 minus x, right? Now this becomes 4x square minus 10x plus 6 minus 4 plus 4x. So that means this is 4x square minus 6x plus 2. Fine. Now we move towards the third case. That means x is greater than or equal to 1 and less than 2. Fine. Now obviously in this case mod x is going to be x because x is positive. Mod of x minus 1, since now x is greater than 1, so it is again positive. That means x minus 1. X minus 1, in this case you have to look for the input. Modulus, the value of the modulus is always positive, but you have to always check for the input. If the input is positive, then it is going to be same as the answer is going to be same as the input. But if the input is negative, then the answer is going to be negative of the input. Fine. Now in this case x is smaller than 2, so that clearly means mod of x minus 2 will be negative of x minus 2. That means 2 minus x. Now let us put in all of these values to get the value for the function. Here we get 2x minus 2 because it is x minus 2 minus x or x plus x minus 2 into 2x minus 3 minus 4 times. Now here it is going to be x minus 1 plus x minus 2. So that means 2x minus 3 into x minus 1. So this becomes 4x square minus 10x plus 6 minus 4 times 2x square minus 5x plus 3 minus 4x square plus 10x minus 6. Fine. Now we move towards the last case, that is x greater than 2. Now students, we discussed the fourth case. In the fourth case we have x greater than or equal to 2. Now when x is greater than or equal to 2, then obviously mod x is equal to x. Mod of x minus 1 will be x minus 1 because x is greater than 1. And mod of x minus 2 will be similarly just equal to x minus 2 because x minus 2 is positive now. Now just put in all of these values in the expression. We'll be getting x, then minus inside the bracket it is x minus 2. So that means this is only 2 into 2x minus 3 minus 4 times it is x minus 1 minus inside the bracket x minus 2. So that means this is minus x plus 2, or this is just 1. into x minus 1, right? So finally we'll be getting 4x minus 6 minus 4x plus 4, or this is just minus 2. So that means fx is equal to minus 2 when x is greater than or equal to 2. Now let us collect all the cases to write fx. Now obviously fx is going to come as a branched function. First of all, we had the expression for x less than 0. It was 2. For x greater than or equal to 0 and less than 1, it is 4x square minus 6x plus 2. For x greater than or equal to 1 and less than 2, it is minus 4x square plus 10x minus 6. X greater than or equal to 2, it is minus 2, right? Now from here, we can directly write the derivative of fx, that is f dash x. So for x less than 0, it is 0. Between 0 to 1, it is going to be 8x minus 6. Between 1 to 2, it is minus 8x plus 10. For x greater than or equal to 2, it is just 0. Now students, we have to find the points of non-differentiability for this function. And you are clearly seeing fx is basically a polynomial function which is changing its definition at few points. Like at 0 it is changing its definition, at 1 it is changing its definition, and then again at 2 it is changing its definition. That means these are 3 susceptible points where non-differentiability can occur. At rest all other points, since it's a differentiable, since it's a polynomial function, so it will be obviously differentiable. So now we have to discuss its differentiability at the points 0, 1 and 2. Now let's find the value of left hand derivative at x equal to 0. Now obviously at x equal to 0, the value is 0. The value of LHD is 0. Now if we discuss RHD, that is right hand derivative at x equal to 0, so we'll have to consider this function now because it is lying on the right hand side of 0. So it is 8x minus 6. Just put x as 0 in this, you will be getting minus 6. Now clearly these two values are unequal. So that means the function is non-differentiable at x equal to 0, right? Now for x equal to 1, if we find LHD at x equal to 1, so students, it comes as 8 minus 6, which is 2, right? And RHD at x equal to 1, if I find out, it is going to be 10 minus 8, which is again 2. Now this is differentiable. Fine, because both of these values are equal. And now if we discuss the differentiability at x equal to 2, that means we find LHD at x equal to 2. It becomes minus 16 plus 10, which is minus 6. And if I find the value of RHD at x equal to 2, it becomes how much? It is just 0. Now since minus 6 and 0 are unequal, so that means the function is again non-differentiable at x equal to 2. So that means there are 2 points of non-differentiability, that is 0 and 2. So hence option C is the correct one, right? Now students, we have completed all the questions of part 2 for KVPY SPSX stream. In the upcoming videos, I will be posting questions from different exams. So keep watching my videos. And if you have not subscribed my channel till now, I will strongly suggest you people to subscribe it, because it is going to help you a lot if you are preparing for any entrance exam like JEE Main, JEE Advanced, or Olympiads. Thanks. Keep working hard and share my videos among your friends as well.